Welcome to Structural Analysis 2 video series. This one is read number 5th. Second part is Approximate Analysis of Multistoried Frame. Introduction. In an approximate method of analysis, statically indeterminate structure is converted to statically determinate structure by making a approximate assumption and then analyze for the member forces using a law of static. So there are two methods for the horizontal load. One is a portal frame method and cantilever method. So when there are horizontal load acting on the frame, two methods are there: portal method and cantilever method. And when vertical load is acting on the frame, in that case it may be UDL on the beam. In that case, the substitute frame method is there. So the first horizontal loads means if this one is your portal frame, uh, let's take 2B. So the loads are acting horizontally on the frame. In that case, these two methods are there, and when the loads are vertical, means if there is UDL on the frame, then the substitute frame method is there. Okay, so these are the methods which approximate method through which we can find out the or we can analyze the frame. Now first method is portal frame method. So there are portal frame methods are used to analyze the building frame subjected to lateral loads. In the figure you can see these are the lateral load acting on the frame, and this method is approximate or more approximate to the low rise buildings frames. That means you can say that the height of a structure is less than the width of a frame. So for them it is more approximate to low rise building frames. And the assumptions made for the this analysis, first one is the point of contraflexure is located at the center of each column and beam. So if you draw the bending moment for the beam, it will be varying from the center. When they are subjected to point load, it will be straight line. So if you draw for the column, it will be the point of contraflexure is assumed at the center point. Second thing, the horizontal shear is divided among all the column on basis that each interior column take twice as much as exterior column. So if there are two forces acting P1 and P2 on the frame, and if shear is happening here on the column, so the interior column, these are the two are the interior column, the shear will be 2h, and the external column taking a shear of h. That means if external column taking a shear h, to resist these two horizontal reaction or forces P1 and P2, external column take a h, uh, create H reactions in the horizontal direction to oppose P1 and P2. In the interior column will take 2H. That means interior column will take twice of that exterior column. So that is one assumption. Okay. So these are the two assumption. There is zero bending moment will be at the center or midspan of a beam or column, or point of contraflexure will be at the midspan of a column or beam, and the shear force will be 2h for interior column and h for the exterior column. Now next is the cantilever method. So used for analysis of a building frame subjected to lateral loading. For approximate to the high rise building frame, height is more than the width of a frame. So it is more approximate for the high rise structure. Okay, the assumptions are for the building frame act like cantilever beam with the column or longitudinal fiber of a beam. So due to the high rise building or structure, if the structure is like this and force is acting longitudinal over it, so it will act like a cantilever, and this fiber will be the column fiber will be act like a fiber of a cantilever beam. So that is the first assumption. And the second assumption, as usual, like a previous method, that the point of contrafracture is at the center. So the point of contrafracture at the center for the beam, and if you draw for the column, each column, it will be at the center. Same thing happen for each column. The it will be at the center. Okay. So that is the second assumption, that is a point of contrafracture will be or we have to assume at the center of each column, and for each beam it will be assumed at the center point as a contrafracture. Then the third one is axial force in the column is proportional to the distance from the centroid and the area of the column group at the level. So, or we can say the stress to the distance stress is trace of individual column. If this one is a column, the stress of uh, in this column uh, and distance of CG, if CG is here, let's say x1, they that ratio is proportionate for the each column. So here we can see V here is a force is considering the this bay uh, uh, this taking a section through this column. So there are reaction V1. So V1 divided by area, V1 divided by area divided by this distance center, this if this one is a CG, then the distance of x1 bar is a distance with respect to CG for this column is equal to second V2 divided by A2, V2 divided by A2, and the distance of this column with respect to CG, let's say that what is x2 bar, is equal to this V2 divided by A2, A3 divided by the centroidal distance of a column x3. Then the last column is V4 divided by A4 divided by the centroidal distance with respect to the CG of that column is x bar 4. So these ratios are same. So from this ratio we can find out the this axial force. If this area is area of each column is same, then we can write down it like this: V1 divided by x1 bar is equal to V2 divided by x2 bar is equal to V3 divided by x3 bar is equal to V4 divided by x4 bar. So from this once we know the x1, x2, x3, x4 uh, by doing the once we know this value x1, x2, we can find out this v1 and v2. Okay, and once we know the v1 and v2, we can find out the other forces in the member. Okay, let we stop here. In the next video we will see the problems on this approximate analysis.